When you are working with real-world data, there is one thing that you will run into, which is missing data. Today, I'm going to show you the most common and sane ways to handle missing data in Python using Pandas. Let's dive in. The first step is obviously to spot the missing data. We covered this in a previous video. If you missed it, no pun intended, check it out first. So, what are the common strategies to handle missing data? There are three main ways to deal with missing data. Either remove it, fill it, or predict it with machine learning. Let's start with the easiest. Sometimes, the easiest way to solve a problem is to run away from it. So, when should you drop data? If a column has too many missing values, like for example 90%, it's probably useless, so you can consider dropping it. An example is, if most client addresses are missing, just let that column go. Also, if just a few rows are missing, it's safe to drop those rows. For example, if only 1% of your client records are incomplete, it might not be worth it to spend a lot of time cleaning this part, and you can simply drop it. So, how to drop stuff in Pandas? You can decide to drop a specific column by using the .drop method. You simply specify the column name or the column names and specify the axis to be equal to 1. You can also drop all columns with any missing value using tf.dropNow with an axis equal to 1. You can as well drop columns that have less than x missing values. For example, here we are dropping all columns that have less than 3 non-null values. You can as well drop rows with any missing values by fixing the axis to be equal to 0 instead of 1. And you can as well drop rows with less than x non-null values. Note that by default, the operations we presented early do not change your data frame. If you want to change to apply, either fix in place to be true or reassign again to your data frame. Another quick tip to consider: when we fix the axis to be 0, we are working with rows. When we are fixing the axis to be 1, we are working with columns. Some things to consider before dropping data. First, there is data loss, as you might lose important information. There is also the bias risk, as removing too much can skew your dataset and totally mess with the distribution of your data. Also, context matters, as missing values may carry meaning. It is worth considering to understand why the data is missing before deciding to drop it. The second method is to fill missing data, aka imputation. Here are the most popular ways to fill in missing data. The first and most basic one is to fill in with a constant. For example, here we are filling all missing values with 0 using the .fillNow method. You can also fill with a string. For example, here we are filling all missing values with the string unknown. You can even set different constants per column. A more advanced approach is the forward fill, which means using the previous value. In other words, we are filling missing values using the last known value going down the column. You can also use a backward fill method, which is using the next value, meaning we are filling missing values using the next known value coming up the column. Of course, these two methods work best when the order within your data frame matters. We can as well fill with interpolation, which is great for numerical data. For example, we can fill with a linear interpolation using the df.interpolate method. We can also specify the method to be time, which is a linear interpolation based on time series. This works when the index of your data frame is a date-time index. We can also interpolate using a polynomial interpolation, and we can even fix the order. We can as well use different statistics for filling. For example, we can fill a given column using the mean value, or we can even fix the median value. This is more safe option compared to the average because, as we know, the median value is less sensitive to outliers. We can fill a given column with the most common value in that column using the mode function. We can even fill one column using another this way. The third method is to predict missing values using machine learning. If you're feeling fancy or you have a big dataset, you can train a model to guess at missing values. Yep, that's the thing. It's a bit more advanced, but it can work really well. In this video, we'll explore two machine learning models used to fill in missing values, which are the KNN imputer and the iterative imputer. Let's start first the KNN imputer. The KNN imputer works by finding rows in your dataset that are similar to the ones with missing values. It then fills the missing values by averaging the values from the nearest neighboring rows. It's great for capturing local patterns, and it's very straightforward to use. You can think of it like this. Let's find a few similar rows and take their average to guess the missing value. Here is an example code. Here we are importing Pandas and NumPy. These two packages will be used to create a sample data frame. We import KNN imputer from sklearn.impute as well. We create a sample dataset with some missing values. We define a KNN imputer that averages the values from the closest neighbors. Here we fix only two neighbors. We use it to fill the missing data by training it on the existing values. In our example, the missing value gets filled with the average of the two most similar rows. Next, we have the iterative imputer. The iterative imputer takes things a step further. It uses a machine learning model to predict missing values by learning from the other columns. Think of it like this. Let's build a model to predict the missing values based on the rest of the data. Here is how it works. It fills missing values by predicting them once at a time using the other columns as features. It does this in multiple rounds, refining its predictions each time. It's more powerful than the KNN algorithm, especially when there are complex patterns in your data. Here is an example code. We first import Pandas and NumPy that will be used to create our sample data frame. We import enable iterative imputer to be able to use it. We import iterative imputer, and we import a machine learning model that will be used to predict nans. A typical choice is the random forest algorithm. We then create a sample dataset with missing values. We set up an iterative imputer using a machine learning model like the random forest regressor algorithm. We train the imputer and use it to fill in the missing values. And then we convert the output back to a data frame. In the end, you get missing values filled using a model that understands the relationships between columns, which is very handy for real-world data. Both KNN imputer and iterative imputer are great tools for intelligent data imputation. Use KNN imputer for simpler patterns and quick fixes, and use iterative imputer when you need more accuracy and have complex data relationships. As a conclusion, handling missing data is a key part of data cleaning. You can either drop it, fill it, or predict it. Just make sure your method makes sense for your data and your goals.